Welcome to the Oracle Apex 24/1 End-to-End Product Tour webinar. I'm Steve Minch, an architect on the Apex team, and I'll be your guide throughout the product today. Over 800,000 developers the world over love the Oracle Apex platform because it lets them do more with less. They get more results with less effort because Apex has the most built-in enterprise app features. They build more apps in less time since low coders and pro coders can collaborate to bring their unique value to the solution. They enjoy more productivity with less busy work because Apex has the smartest UX patterns and the Apex service is fully managed and scales automatically. And they can afford to let more stakeholders build and use apps for less cost since Apex puts no limits on the number of apps, users, developers, or amount of data you can use. A company only pays for the CPU and data storage their apps use. Over the next hour, I'll show you how Oracle Apex delivers unrivaled developer productivity with AI assistance throughout the product. Apex is unique in letting developers work with any kind of enterprise data using the same declarative SQL skills. It's an ideal platform to rapidly deliver and evolve enterprise apps for any use case and offers all the critical capabilities the job demands. Along the way, you'll see many of Apex's unique differentiated low-code features that make development a joy. We'll see Apex's features in the context of a demo app for a fictitious ambulatory medical facility called Woods Clinic. A patient inquires about an outpatient medical procedure. Clinic staff approves or rejects the request if it can't be handled automatically. Approved patients receive a welcome email with their login credentials and they complete their registration on the portal. Clinic staff schedules the procedure, and when complete, staff prepares a discharge letter and invoices the patient after checking with their insurance. The app consists of 3 modules, one for patient onboarding, one for the clinic portal and back office app, and a library module with shared components. Much of the app logic is orchestrated using Apex's integrated visual workflow. We'll see the app work with data from external sources like MySQL and OData REST APIs and engage large language models for AI-powered features using OpenAPI and Oracle OCI. Developers Leo and Cecily built the app, and their colleague Adina is the dev manager who looks after work assignments and app source control with GitHub. David is our Woods Clinic back office user, and Enya Enser is the patient we'll follow getting a procedure done at the clinic. We'll start by looking at overall development tools features. Oracle Apex has a built-in issue tracker under team development. It lets teams organize their work into milestones or sprints, and in each sprint, devs can see the issues to work on. Each issue can contain text, images, and attachments to describe the work. Issues are based on an extensible set of templates like this bug template that provides the initial markup to guide users to give the appropriate information. And flexible labels grouped by purpose make it easy to classify and manage issues of any kind. Any enterprise app works with data, and Apex offers efficient tools for quickly creating and visualizing data models and the SQL script to create them. Use quick SQL shorthand to express tables, columns, data types, and relationships with minimal typing. When you pause, the diagram updates in real time to reflect your changes. When ready, you can review and run the SQL script to create the tables. Gartner's Henry Cook called structured query language the eternal golden data language. For 50 years, it's been the preferred declarative way to express what data your apps need to retrieve or modify. All the largest enterprise SaaS systems use SQL. Developers on the Apex platform wield the power of the Oracle 23 AI Converged database to work with every kind of data using the same SQL skills. The AI-powered Apex Assistant can help developers write SQL, learn SQL, debug SQL, and write code using PL/SQL, the procedural language extension. For example, while working on a chart, you can ask Apex Assistant in natural language for the sum of the amount due for patient procedures for the preceding 24 months, grouped by month. It can help quickly generate the required select statement and get you on your way. After setting the label and value for the graph, you run your page and see your results. While working on a report, you can ask Apex Assistant to help make a list of patient names, procedure descriptions, total amount, and doctor names for patient procedures in the last 60 days, with the most recent ones first. It can help generate the query you need, and you're running your report in no time. While working on your app, you can ask Apex Assistant for help on any questions or doubts you have about SQL, like what's the difference between a join and a left outer join. It's like having a personal SQL coach and tutor. It can help explain the answer with concrete examples to aid your learning. While writing code, ask Apex Assistant for help on your task at hand, like how to process a list of comma-separated numbers. And boom, it can help generate an explained example with working code you can immediately put to use. Even more complicated programming tasks like writing utility functions can be made easier with the help of Apex Assistant. Just explain what you need, and it can help generate you a solution. Apex Assistant can also help debug SQL, explain error messages, help improve your code implementation, and more. In Oracle Apex, low-coders and pro-coders on a team collaborate around packages. These code modules provide a simple set of functions and procedures that low-code developers can easily engage from pages and workflows by declaratively configuring what values to pass for each parameter. The values can come from items on a page or any other expression without ever having to understand how the package APIs are implemented. In Apex, building pages is productive, iterative, and immediate. The Page Designer layout pane shows a visual representation of how regions and items are positioned relative to each other, like this search region above in the nav bar, and these search results and map regions side by side below it. At any time, you can test the latest version of a page in the browser to try out how it's working. Here we see the search results are working, but the map is not updating to reflect it, so let's fix that. Apex developers add dynamic actions to regions or items to give them interactive behavior. Here, when the search results refresh, we want to refresh the map region. We can save the page and flip back to the browser to see the map now refreshing with each search. Whenever the map is refreshed, let's automatically zoom and center the map too. Again, we add a dynamic action and configure it to do just that. Flipping back to the page, we can immediately see the effect. No slow compilation or deploy steps involved to iteratively see the fruits of your labor. Just quick results that are easy to achieve. Oracle Apex comes with an industry-leading set of data-savvy UX patterns shown here in the Create Page Wizard gallery. You simply tell Apex's built-in region types what data you need them to work with, and Apex does the rest. If you've ever shopped on Amazon.com, you're familiar with a faceted search interface. Users love them, but they're hard to build, unless you're using Apex. Just pick a table and decide what facets you want your user to be able to search on, and the job is done. Users can search by text or narrow the results using any combination of facets. Apex makes it so, with no effort. You can easily combine the region types on the same page, for example, to have a faceted search that shows its results as cards. Just change the results region type to cards and configure what data you'd like to see in each slot of the card display. In the Woods Clinic app, the Patients page also adds a map region using dynamic actions to refresh and zoom the search-filtered results, all with no code. It even has a facet that uses spatial data features to filter patients by the distance away from the clinic that they live. No other low-code application platform offers anything close to Apex's sophisticated set of built-in UX patterns. The interactive report is another popular UX pattern. Just by configuring the data source on the region to work with medical procedures, a Woods Clinic user like David gets a customizable reporting facility he can use to create as many different procedure-related reports as he needs to get his job done. To focus his attention on paid procedures for LASIK laser vision correction, he adds 2 filters using the action menu. To break the results into groups by the doctor who performed the procedure, he adds a control break by doctor name. His boss is interested to know if any patients have traveled over 30 kilometers to get to the clinic, so David adds a conditional highlight to show those customers in a different color. To add a sum of amount due to each break group, David adds an aggregate, picks sum for the function, and chooses amount due for the column. And now each group has totals. Since he may need to run this report again, he saves the report with the name LASIK Procedures by Doctor, and resets the default or primary report. He can now choose his saved report from the personalized list anytime he needs it. He can download the results in CSV, HTML, Excel, or PDF format, or send it to a colleague in email. If it's a result he'd like to receive himself in email on a regular schedule, he can also subscribe to the report and indicate format and frequency. Whenever necessary, David can also add a graph to his report. For example, to see a count of the insurance company ratings as a bar chart for the filtered LASIK procedures, he can do that in a few clicks. and toggle between tabular and graphical views of the report at any time. Oracle Apex has a vibrant developer community and supports many kinds of plugin extension components. At the community-run marketplace on apex.world, it's quick to search the over 400 plugins available. We'll use a plugin to build a Kanban board to visualize pending medical procedures at the clinic. After downloading the plugin, we import it into the clinic app. In a new blank procedure radar page, we add a new Kanban region to the page and run. By default, it's configured to show dummy data and use 3 common statuses. First, we update the JSON that defines the status columns to reflect the awaiting schedule, scheduled, completed, and invoice statuses we need. Then we update the query to change it to show our medical procedures. We ask Apex Assistant to help rewrite the query to be based on our patient procedures view and explain how we want the statuses to be mapped to Kanban column numbers. Running the page, we now see our custom statuses and our patient procedures currently in the dev environment. In the awaiting scheduled column, we notice Ziggy Zeckelman's card has the word with but no doctor's name since it hasn't been scheduled yet. We select the expression used for the card footer and ask Apex Assistant to help fix that for us. It helps explain the case statement we need that we paste into the query to get the job done. And now things are looking great. The plugin even supports interactive drag and drop of cards between Kanban columns. To get that working, later we'd need to write a bit of code to handle the drop appropriately using the predefined bind variables the plugin has defined for this purpose. In this section, we saw a wide variety of Apex Developer Tools features. We'll focus next on capabilities it provides for user experience design. In Oracle Apex, you can create an app with the help of generative AI. Just explain the purpose of your solution in natural language, including the kinds of pages you want and any particular features you'd like the app to have. And the Apex Assistant can help propose a set of pages and options that meet your needs. It's a conversation, so you can add additional options you think of like access control list, based security, and the ability for users to leave feedback. If you think of additional pages you need, just ask. Here we asked for an additional faceted search page and a dashboard we forgot to mention earlier. When done, click Create Application to see a blueprint overview of the app to be created. There you can choose the appearance, add any additional features like PWA and push notifications, and click Create App again to finish. This gives you a great head start for adding additional features that only you know how to do. Apex makes it easy to create responsive pages that look great on any desktop or mobile screen size. Developers use a 12-column layout that automatically fills the space available. They also decide when a page component like a region or item should sit on the same line as the one before it, or else start on a new line. When combined with the ability to nest regions inside other regions, these two simple concepts elegantly deliver great results without requiring developers to master CSS. They can let Apex automatically decide in what column a component should start and how many columns it should occupy, or they can explicitly set those when needed to get the effect they're after. To put a component on the same line as the one before it, just deselect the Start New Row switch, and then they'll be side by side. At any time, you can run your page on any supported device to see how its responsive behavior is working. Apex also simplifies pages with common patterns like parent-child relationships and conditional dynamic behavior. It offers 3 types of master detail regions in the Create Page wizard with stacked, side-by-side, and drill-down interaction models. And when creating pages where one item's value depends on another's, developers simply configure the so-called parent item name, and Apex handles the rest. Choosing a different medical procedure automatically updates the list of doctors who are available to perform that procedure. Some eye procedures like cataract removal and LASIK need additional info about the left and right eye that should only appear when relevant. This interactivity is also easy to do in Apex, using dynamic actions with declaratively configured client-side conditions to show and hide the appropriate page elements under the expected conditions. When an app needs an AI-powered chatbot, it's easy with Apex. The Woods Clinic Procedure Inquiry page can help give patients an assistant that can help answer common questions about the clinic's procedures, It knows about procedures offered, their prices and duration, and can help explain details in layman's terms about each one. It can help handle frequently asked questions about getting to the clinic and can help direct users to fill out the inquiry form to get started. Developers open the AI assistant using a dedicated dynamic action step. In the property editor, they configure the welcome message and a system prompt that gives the chatbot its mission. You can choose a dialog display or show it inline in the page. This one line of code assigns a long system prompt to an application item. It instructs the assistant to be a helpful and friendly customer service agent and injects the details about the clinic's procedures at just the right point in the text. To be visualized on maps and useful in spatial data queries, addresses need geocoding. This is easy with Apex. Patient Enya Ensor uses the Woods Clinic procedure inquiry page to enter her address, and the page automatically validates it and shows where it is on a map. The page uses Apex's built-in geocoded address page item and reacts to the user's confirmation by setting the latitude, longitude, and city items based on the geocoding info returned by Apex's free geocoding cloud service. Once the geocoded address is in the system, it shows up on a map in the patient's profile for David in the back office app. Apex apps can be installed like native apps on desktop and mobile devices. David's using the Clinic app launched natively from the dock on his iMac at the office. Notice it has no browser address bar. It appears in David's dock like other apps, launches instantly, and keeps David logged in. Enya Ensor gets an email on her iPhone that her hernia procedure was approved, and she clicks on the link to log into the Woods Clinic portal. After changing her initial password, she logs in to complete her registration as requested. Clicking on the app install icon in the nav bar, she sees instructions on how to install the app. Following them, she now has a Woods Clinic app icon on her home screen to tap anytime she needs it. Under Settings, she enables push notifications, so she'll get notified for anything important about her procedure. Tapping to complete her registration, Enya allows the app to use her GPS position and enters her birthday year, month, and day. On the next step, she enters her health insurance policy number and uses her iPhone's camera to snap a picture of her proof of insurance. Tapping Finish, she completes the registration process. Back in David's Clinic app for staff members, he can see Enya's proof of insurance and the GPS location from where she uploaded it. In Page Designer, we can see the registration page use the Get Current Position dynamic action step to declaratively capture the mobile device's location. It configures latitude and longitude items that are automatically populated with that info when the page loads. Enabling Progressive Web App or PWA installation was a single switch to enable in the Apex app definition. Notifying users with email and push notifications is easy. In the Procedure Radar page, David sees Enya Ensor is awaiting scheduling for a hernia operation, so he goes over to the scheduling page to schedule it. He sets a date, time, and doctor, and saves the changes. The calendar updates to reflect the new appointment, and back on the radar page we see Enya's progress to the scheduled column on the Kanban board. Enya's phone received a push notification about her hernia operation with the date, time, and doctor info. She also received the same information in an email. In the Apex Builder, we can see the email template used to send that message Enya received. It has HTML markup and named placeholders surrounded by hash signs. When using the declarative page process for sending email, developers choose an email template and configure the values for the placeholders. Using the built-in process for sending push notifications is even simpler. Just configure the username to notify, a subject line, and a message body. With Apex, showing end users the progress of a workflow instance is straightforward. Clicking the icon on the Recent Inquiries page for patient Harry Hu opens a dialog showing the status of his onboarding workflow. Going from left to right, we can see his address was within the clinic's service area, his insurance provider was predicted to be low risk, and he was auto-approved. His account was provisioned and he's already completed his registration. Leo created this dialog in less than a minute. He only needed to use the built-in workflow diagram region and configure a page item to provide the workflow ID to visualize. Enforcing consistency across pages is easy using template components and component groups. Notice in the workflow status dialog, we have a toolbar with a refresh icon above a content area showing the diagram. The same construct repeats in the Pending Procedures page, where we again have a toolbar with a content row region below. And the Patient Discharge form has a toolbar with content on both the Procedure Info tab as well as the Discharge Letter tab. Apex lets teams crystallize repeating UX patterns into reusable template components. Here on the Workflow Status page, we see it's using a Content with Action Buttons component that provides an Action Button slot and a Main Content slot. Similarly, on the Pending Procedures page, the same Content with Action Buttons template component is in use, but instead of a workflow diagram in the Main Content slot, this page uses a content row region there. Our reusable components live in the Library app in the Shared Components area under Plugins. Editing the Content with Action Buttons plugin, we see its definition is supremely simple, just a tiny bit of HTML markup with named placeholders for a custom attribute named height and 2 slots, Action Buttons and Main Content. The plugin defines a single custom attribute and 2 slots whose names we just saw in the component markup. Each slot can configure what kind of content is allowed inside, and the page designer enforces those rules to ensure developers use the components in the intended way. Notice the Action Button slot can only contain buttons, while the Main Content slot can only contain regions. To dramatically simplify reuse, Apex provides component groups. Use them to define a named set of components to reuse and refresh in a single click. The Woods Component Library group contains 4 email templates and 2 template components. One is the Content with Action Buttons used by the page pattern, or usable on its own. The other is a PDF viewer component. The Woods Clinic app subscribes to the Woods Component Library component group, and we can see its status is up to date. Looking at one of the components from the subscribe group like Content with Action Buttons, we see it's read-only in the subscribing app. This ensures developers always use the central definition provided by the Library app. The powerful combination of template components and component groups give Apex developers a leg up in delivering consistent apps and a powerful tool to save development time across the entire team. Template components also let anyone familiar with HTML build reusable UI widgets teammates can use like native ones in Page Designer. For example, developers configure this metric card's attributes in the property editor. When creating the metric card component, we define any number of custom attributes it needs to do its job, and then can reference the custom attribute values in the component's HTML markup. Notice the use of the if directives for easy conditional rendering, depending on the values of the custom attributes. Using the with apply directive, components can reuse other components, passing along any required attribute values needed. Here the metric card is using a theme badge component as part of its layout to show a stock's percentage change. Composing multiple components is just as easy, so this metric card composes a spark chart component to show a subtle price history graph of the stock featured on the card. The spark chart is another template component defined with the simple markup you see here. It's reusing the OJ spark chart component from the Oracle Jet library. In Page Designer, we see the metric card appears in the palette, and its attributes are configured to show ticker, current price, company, and trend from the region's data source query results. At runtime, we see the beautiful, subtle animated charts on each card as we page through the stock prices. And here, the spark chart is used in a column of a report as well. Enterprise app users often need to search for data. With Oracle Apex, developers can easily give end users a Google-style search experience over any kind of app data. In this example, the app-wide search is configured to find countries, employees, departments, people, or the names of pages in the current app. Typing King into the search bar, the results appear showing a matching employee, some countries, and a couple of people like King Ludwig and BB King. Clicking on his card opens an appropriate person edit page, while clicking on an employee search hit opens an employee page. To use this feature, developers define search configurations for each data source they want to search over, supporting local database, REST APIs, and Oracle Text full-text searching with fuzzy text matching capabilities. For each search config, like this people one, after defining the data source, developers configure how selected columns map into canonical search result positions, like title, subtitle, description, and more. Then they define the link details specific to this kind of search results. Developers then use a search region to add the Google-style search results to a page. It simply mentions which search configurations it should include, and Apex does the rest. Search results across all these search configurations are presented to users in a flexible, consistent way at runtime. In this section, we saw many examples of Oracle Apex's user experience design capabilities. Let's look next into those related to process and business logic features. Oracle Apex has integrated visual workflow that's easy to use and extensible. Looking at recent patient inquiries at the clinic, we can see by the workflow diagram that Ann Alt's request was rejected because her address was outside the clinic's service range. Cindy Sent's inquiry was also rejected, but this time because the clinic application used machine learning to predict that based on historical experience, her insurance provider was risky to reimburse for the cost of the procedure requested. Bob Bunn's request was queued for manual approval since the machine learning predictions weren't able to confidently auto-approve or auto-reject the request. A clinic staff member like David approved the request after considering the details more carefully. Cecily created this patient onboarding workflow using Oracle Apex's integrated visual workflow designer. It contains activities to evaluate the patient's proximity to the clinic, evaluate their insurance risk, predict the request's approval using machine learning based on historical cases, require human approval when necessary, provision an approved patient's account, and then wait for them to complete their registration on the online portal. Cecily and Leo collaborated on this workflow. She declaratively configured activities to engage business logic that Leo created in this FRC onboarding package module that encapsulates the logic the business process requires. For example, this evaluate proximity function, evaluate risk function, and predict approval function. The body of the package contains the implementation details of the module's public APIs. For the evaluate proximity function, we see the implementation is effectively a single SQL statement that uses the SDO distance function to compute how far away the patient's address is from the clinic. The case statement returns out of range if the distance is greater than 400 kilometers and within range otherwise. The evaluate risk activity invokes the evaluate risk function in Leo's FRC onboarding package. This returns risky if the machine learning prediction returns auto-rejected, otherwise returns the string low risk. The machine learning decision function is again essentially a single SQL statement using the prediction function with the neural network model whose name starts with NN_ to predict the outcome of the patient onboarding approval based on historical cases at the clinic. It's using the patient's insurance provider and the initial procedure they're requesting as input parameters. The model name, NN_6553F4D64D, was generated by the Oracle AutoML tool that Leo used to automatically suggest the best machine learning algorithm to use on Leo's data for the prediction he needed to make on the clinic's historical information. Oracle Apex features integrated human task approvals that dovetail seamlessly with workflow. The diagram for patient Julia Jones shows her request is pending manual approval, so David heads over to his approvals page in the Clinic app to review her case. Leo generated this task details page automatically in the Apex Builder while defining the new patient approval task definition. He subsequently modified it in Page Designer to add additional specific details about the new patient approval task. He sees his previous comment and adds another comment to the approval task that he's definitely rejecting. Then he clicks on Reject to send the request on its way. The patient onboarding workflow automatically continues and based on the rejected outcome notifies the patient that she'll need to seek out a different facility for her cataract procedure. Cecily's switch activity in the onboarding workflow uses the outcome of the approval, saved automatically by Apex Workflow in the task_outcome workflow variable to route the request based on whether the outcome was rejected or approved. In Apex, visual business logic can easily react to data changes. In fact, a visual workflow directs the lifecycle of Enya Enser's medical procedure. The workflow waits for a data change on the medical procedure status or scheduled date fields and visually orchestrates what processing needs to happen in reaction to those changes. As we saw before, when David scheduled Enya's procedure, she received both an email and a push notification. This diagram visually explains that those were both triggered by the procedure lifecycle workflow. Similarly, when the procedure status changes to completed, the workflow prepares an invoice for review by staff. After a clinic staff member has reviewed the invoice, the procedure status changes to invoiced, and we see that the workflow will email the invoice to the patient. In the Workflow Designer, we see the Prepare Invoice activity calls Leo's Prepare Procedure Invoice API in the FRC Clinic package, and the Email Invoice, Email Schedule Info, and Push Notify Patient activities are also declaratively configured. Any workflow activity can use a SQL query to retrieve additional data it needs to perform its task, so this Email Schedule Info activity defines a query to retrieve all the information required by the procedure's schedule change email templates, placeholders. The developer can reference any selected column retrieved by the query by just using this ampersand notation and its column name. The Push Notify Patient activity uses an additional data query in a similar way, referencing its data using the ampersand column notation in the push message body text. Data validation is easy with Oracle Apex. When attempting to reschedule Enya Enser's procedure, if David enters a time that would make the procedure fall outside of business hours from 9 a.m. to 6 p.m., he sees a friendly validation message letting him know it's not allowed. In Page Designer, Leo defined a validation that passes the procedure date and duration hours field values to a validate procedure time function in the FRC Clinic package. It uses simple logic to determine if the procedure's time interval falls within working hours and returns true if the data is okay, or false if it's not. If the validation fails, Apex automatically displays the friendly error message to the end user. Parent-child constraints are another common kind of validation in enterprise apps that Apex makes easy using the power of SQL. Imagine an action item in a Woods teamwork app where the user has to assign staff members responsible for delivering the action item. The app needs to enforce that each action team needs a lead, that there can only be one lead per team, and that the team contains no duplicate team members. These are all data validations about a parent action team that needs to reason over the collection of child data, in this case, the set of action team members. In Apex, these kinds of parent-child constraints are easily enforced using simple SQL statements. The enforce exactly one lead page process invokes the one lead per action team procedure. That uses a select count query to count the pending team members that are leads for the current action team, and if the number is not equal to 1, conditionally returns an appropriate error message depending on whether the count is less than 1 or not. The enforce no duplicate team members page process invokes a similarly named procedure. Again, using the power of SQL, it uses a query with a group by and having count star greater than 1 to identify if there are any duplicate team members. These kinds of parent-child constraint validations require significant code and effort in other application platforms. In Apex, the pending changes are conveniently visible to the powerful SQL language, and if the validation raises an error, the transaction is rolled back so no bad data can ever be saved to the system of record. Apex apps can easily incorporate generative AI using large language models from OpenAI, Oracle OCI, or Cohere. Other AI service providers will be supported in the future. At Woods Clinic, staff members complained that writing patient discharge letters was taking too much time. Leo addressed the problem by incorporating generative AI into the complete procedure page in the Clinic app. Now, David can just indicate the general discharge recommendations, any suggested over-the-counter pain medication, and enter the doctor's prescriptions for the patient in question. Then, on the Discharge Letter tab, David can click the Generate Initial Letter button, and generative AI can help synthesize the information provided and can help produce a draft of the discharge letter David can edit as needed. It can quickly help produce the discharge letter for Enya Enser after her hernia repair procedure was completed, saving David a lot of time. To show off how easy it is to incorporate multiple different generative AI surfaces, the Woods Clinic includes a menu option to choose the Oracle OCI AI service instead of the default OpenAI one. After enabling that switch, repeating the Generate Discharge Letter can help produce a result with a recognizably different flavor to the previous one, but just as valid to save David time in preparing the entire letter by hand. Leo used a static application file for the AI prompt text that helps generate the discharge letter. It includes substitution tokens using the familiar Apex ampersand dot notation for patient, doctor, and procedure, as well as simple if directives to conditionally include text in the prompt for general recommendations, an over-the-counter pain recommendation, and the patient's prescriptions, but only if a value is provided for those variables. In the FRC Clinic AI package, The generate discharge letter contains the small amount of code required to populate the AI prompt template with appropriate values for patient, procedure, general recs, pain rec, and prescription token values. Notice it gets the job done with two handy SQL statements. One retrieves the patient name and medical procedure given the supplied medical procedure ID, and the other produces a semicolon-separated list of prescriptions the user has typed into the page. The call to the generate function in the Apex AI package helps to interact with the chosen AI service, abstracting the details of working with OpenAI, Oracle OCI AI, or Cohere so that the Apex developer doesn't need to care about those differences. The two AI services we're using in the Woods Clinic demo are defined in the Apex Builder in the Generative AI Services page. For even more powerful AI functionality that incorporates private application data into the mix, Oracle Apex developers can easily do semantic similarity searching and retrieval-augmented generation using the help of Oracle 23 AI Vector Search. Again, basic SQL skills are all a low-code developer needs to leverage this amazingly powerful capability. Using the DBMS vector load Onyx model procedure, devs can load any industry-standard neural network exchange model into the database. This defines the standard bytecode, if you will, for a particular kind of neural network that's been trained on an appropriate dataset for your application's purposes. With this Onyx model loaded, developers can then use the toVector function to encode their business app data into a vector that represents an embedding of the input data according to the model in use. When end users need to find results, developers again use the toVector function to produce a vector encoding the user's search expression. And finally, using the database's built-in vector distance function, the developer uses a simple SQL statement to order by this distance to find the top-end closest results in the database. This closeness is defined by the semantics encoded by the model into those vectors, which sounds complicated, but where the rubber meets the road for end users, it means that the results they see are the ones that are semantically most relevant to their search. End users love how this helps them find a needle in a haystack and makes developers like Leo and Cecily heroes. Apex developers can use the same vector search capabilities to help augment the accuracy and relevance of their large language model generative AI results. This starts by using the functions in the DBMS vector chain package to help chunk a company's textual data into smaller pieces like paragraphs, sentences, or words. Then, developers encode these smaller data chunks using the selected Onyx model to produce semantic vector embeddings for the chunks. Finally, they use a similar kind of vector search as before to find the chunks relevant to a user's search and send only those identified chunks along with the AI prompt to the large language model. This optimizes the data sent to the LLM, provides much better generative AI results, and saves the company money by avoiding sending tons of irrelevant tokens to the LLM. Apex has built-in support for remote printing since every enterprise app needs some kind of pixel-perfect reports. There are 2 Oracle options and 1 third-party option. Several other solutions integrate with Apex using plugins, so developers are spoiled for choice. Recall that when David marked Enya Enser's procedure as complete and produced a discharge letter, the procedure lifecycle workflow reacted by automatically generating the invoice. In the Review Invoices page, David can see Enya Enser's invoice data, as well as preview the generated PDF. To design the invoice, Leo used Microsoft Word to create the template, using any available feature of Word to format the result. He used special tags surrounded by curly braces where he wanted the patient procedure data to be substituted during printing. Leo used a report query to define the SQL statement to retrieve the data the invoice requires and click the download button to download a sample JSON file to study. The structure of the JSON helped him formulate the right tag names to use in the Word template. Then he created a report layout and uploaded his Word template document with drag and drop. The prepare invoice activity in the procedure lifecycle workflow invokes the prepare procedure invoice procedure in the FRC clinic package. It uses the generate document function in the Apex print package to produce the PDF, passing in the report query and report layout to use. Apex hides all the details of producing the report behind this simple API, as well as providing various declarative options for generating and downloading the PDF as well. Apex simplifies offloading long-running processes to be done in the background to give end users the best experience. Reviewing Enya Enser's invoice, David calls up Kaiser Insurance to learn they will reimburse $8,800 of Enya's medical expenses. He enters this amount and tabs out to see the Patient Pays field has recalculated dynamically to show Enya will only owe $50 out of pocket for her hernia operation. After making this adjustment, David chooses to regenerate the invoice. David can immediately continue with his work, visiting other pages in the app while the invoice printing happens as soon as it can in the background. Back on the Review Invoices page, he reviews the invoice again to see that it now reflects the adjusted insurance amount, so he marks it as complete. In the process, the status of Enya's medical procedure gets changed to invoiced. And on the Procedure Radar page, we see Enya Enser is moved to the invoiced column. Implementing the background printing was easy for Leo. He simply selects the Generate Invoice in the background execution chain in his page and switched the Run in Background switch to On. Any child processes of that execution chain now run in the background, so this call to the Generate Invoice procedure happens that way. Since the procedure status is now changed to invoiced, the procedure lifecycle workflow automatically emailed Enya the invoice as a PDF attachment, which she received and reviews on her iPhone. Enya calls the clinic to pay her balance, and David now marks the invoice as paid. This causes Enya Enser to graduate off the Kanban board. In this section, we saw lots of examples of Oracle Apex's process and business logic design features. Next, let's examine its application and data connectivity capabilities. Apex makes it easy to work with data from remote databases and REST APIs. In the Woods Clinic demo, Leo gets the data about medical procedures from the procedures table in a remote MySQL database. Clicking Test Operation, we see the live data that confirms this MySQL REST data source is working. The doctor's data in the demo comes from an OData 4.0 REST API. Again, we can test the operation to see the live data. The drug names REST data source uses the simple HTTP adapter to retrieve data from a National Institutes of Health public REST API. Apex supports various strategies for paging through REST API data, so notice we can retrieve the second and third page of results. Often, Fusion Applications customers use Oracle Apex to build SaaS extensions or to create simpler targeted UIs to speed up a business process. This is an Apex REST data source using the Oracle Cloud Applications adapter to work with the Leads business object in Fusion Apps CRM pillar. Out of the box, it supports all of the CRUD operations, so building Apex apps against Fusion Applications business objects is as easy as working with local tables. To prove that, we'll use the Create Page wizard to create an interactive report and form pages based on this Leads REST data source. We can immediately log in with seamless integration with the Fusion Apps single sign-on, using Oracle Apex's built-in social sign-in authentication scheme. We can then instantly query and update Fusion Apps Leads data with no code. All query filters are intelligently delegated to the Fusion Apps REST API backend, and only attributes required by the current region are retrieved, which delivers the best end-user experience. All Apex REST data sources support optional data synchronization. Developers can configure a synchronization schedule, and Apex automatically keeps a local cache table in sync with remote data on the indicated interval. Developers can use the local cache table automatically by flipping a single declarative switch. This can dramatically improve performance for less frequently changing remote data. Creating application REST APIs is simple with Apex. Developers can auto-REST enable any table, view, package, procedure, function, or materialize view in a single click. Or when they need more control, they can define their own modules with URL templates and REST operation handlers to craft get, post, put, patch, and delete operations that do exactly what they need. Often, writing a simple SQL query is all that's required for get operations, while ones that change data like post can call a custom procedure like this FRC reschedule procedure. As usual, the implementation may be just a simple SQL insert, update, or delete statement, or it can involve any amount of custom code as necessary. Oracle Apex uniquely lets developers easily blend remote REST data with local app data. They can augment the results of a REST data source by writing a custom SQL query that references the remote data as an inline view using the special Apex $source data substitution string. They can join it with any other data source to enrich or post-process the retrieved data in any clever way needed. JSON relational duality views and multi-language engine JavaScript are a powerful duo Apex devs can use to simplify building REST APIs. Most application REST APIs require surfacing application data in a JSON payload from multiple underlying tables. For example, in the Woods Clinic app, an invoice REST service payload needs data from the invoices, patient procedures, medical procedures, patients, and doctors tables. JSON relational duality views use a declarative syntax to express how multiple tables participate in a structured JSON document. This is the DDL syntax to create an FRC invoices DV duality view that produces the JSON payload we just saw. The @update annotation means the developer wants the JSON documents to be updatable, and the duality view automatically persists changes to the appropriate underlying table with no code required. A duality view can be auto-REST enabled for direct REST access to read and write the JSON documents in the view, or developers can define custom get and put handlers for finer control. As usual, the get method can be a simple SQL statement, while the put method uses a put invoice function in a JavaScript module with zero latency data access running inside the Oracle 23 AI database. Since JSON stands for JavaScript Object Notation, it's understandable that JavaScript is especially good at working with JSON data structures. The put invoice function can easily reference any data in the incoming JSON document using simple dot notation. Here, Leo is checking to ensure that the value of insurance covered is less than or equal to the total amount of the medical procedure. If not, then it throws a validation error. If the validation succeeds, the function uses a single, simple update statement to save the JSON document to the duality view. The duality view automatically handles how to save any changes into the underlying tables. This is dramatically simpler to work with JSON and relational data this way. In the Review Invoices page, David reviews invoice number 2 for Frida-Foot's LASIK laser vision correction procedure. He notes that at the moment, the insurance coverage value is 0. Using Postman, we exercise the get method of the invoice REST API that uses a JSON duality view, and it returns the invoice JSON payload for invoice number 2. We copy the response payload and paste it into the request payload of a put request, and update the insurance covered value in the JSON document to 5,500. Clicking on Send, we get an error status 400 with an error message that the insurance covered value exceeds the total amount. We update the value to just 3,000 instead and click Send. This time we get a successful response code 200, and back in the Review Invoices page, we see the duality view has successfully updated the FRC invoices table to reflect the 3,000 insurance covers amount. Notice this ETAG value that ends with C047. If we retrieve invoice number 2 again using the get method, we see the insurance covered amount is the latest 3,000 value, and the ETAG has changed to one that ends with 1B37. If we try to submit an update to the REST API using a document with a now stale ETAG value, we get an error. Another user has changed the row, ETAG mismatch. To update the data successfully, we need to use the latest JSON document with the latest ETAG value and modify that document's insurance covered value. After doing that, our put request succeeds as expected, and again the change is reflected in the Woods Clinic portal app page as well. This shows how JSON relational duality views not only implement the JSON to relational persistence, they also enforce lost update protection using ETAGs to avoid users or remote systems inadvertently updating stale versions of the data they might have cached. Earlier we saw secure push notifications at work. Apex makes them easy for low-code developers to use, but that simplicity requires sophistication under the covers. Apex implements the elliptic curve cryptography required to keep the push notification messages secure and abstracts the details of working with the push notification REST APIs from the 4 major notification services: Apple, Google, Mozilla, and Microsoft. The Apex developer just configures the username to notify, the message subject and body, and Apex worries about all the technical details of delivering the notification. Oracle Apex can create an entire REST catalog from a single OpenAPI specification document. Most REST APIs, including ones defined by Apex, can describe their set of endpoints and methods and parameters using this industry-standard JSON format. Let's look at a simple example of pointing Oracle Apex at the OpenAPI document for the REST API of the Spotify music service. After selecting the OpenAPI JSON file and finishing the wizard, the Apex builder creates a new Spotify Web API REST catalog. Exploring its contents, we see all of the service's REST API endpoints have been created automatically. Using any one of them in an Apex app is just a click away to pick it from the catalog. Frequently, enterprise app integration involves loading data from external systems, and Apex supports background data loading to make this task easy for developers. After uploading a zip file of external sales data, we click the Load Data button to start the background data load. Refreshing the page as the loading happens in the background, we see that 10,000 rows of sales data get loaded in just a few seconds without blocking the user interface. In this section, we saw numerous concrete examples of Oracle Apex's application and data connectivity functionality. Next, let's learn how Apex developers tackle application testing. Apex developers use the open-source UT-PL/SQL framework for unit testing. They develop test suites using PL/SQL packages that use special annotation comments to identify the test suite name and the test case procedures. In the package body, they implement each test case by writing code that exercises some aspect of their business logic and then calls appropriate ut.expect procedures to verify if the result is as expected. Developers can run their tests right in the SQL commands window by typing ut.run to instantly check if their changes have broken anything. They can also run the unit tests using the UT-PL/SQL command line utility that can be incorporated into scripts and CI/CD build pipelines. It can produce code coverage reports, so developers can identify future testing opportunities to make steady progress towards testing every line of their code base. Apex developers typically use Cypress for end-to-end UI testing. It has an English-like syntax developers appreciate. Here's a simple Cypress script Leo wrote for validating the login to a Woods HR app. He uses cy.get to get the username UI text field on the page and type a username into it. And again cy.get to get the login button on the page and click it. To assert what should be the expected results, he uses cy.get to get a report region to check that it should contain the value atoms. Leo finds Cypress very productive because it has a nice Chrome extension that restarts the test in the browser each time you save your test in your favorite editor. It lets him easily follow the steps and outcomes and see the live application in the browser as it runs. The Cypress test can also run in a headless way to be incorporated along with UT-PL/SQL tests as part of CI/CD pipelines. In this section, we saw the two popular ways that Apex developers do their application testing. Next, we explore how they do their DevOps. Leo starts in team development, where he reviews ticket number 8. It's a bug report saying the dashboard page is not showing a full 2 years of history. Adina is also asking him to update the term dashboard to overview that she thinks clinic staff members will find easier to understand. He tries the dashboard page and sees that the gross revenue by month ends in December 2023, even though we're currently in May, so he understands the problem to fix. Leo creates a working copy for the clinic app, names it Woods 8 after the ticket he's working on, gives a description, and clicks Create. In the working copy, he makes the changes, starting with the dashboard page. He changes gross to total in the chart title, changes the page name, alias, and title to overview, and sets the maximum rows to process on all the chart series to 24 and saves his changes. He edits the breadcrumb entry for the dashboard page to change the name to overview there too. And lastly, he edits the navigation menu entry to change dashboard to overview. He quickly runs his unit tests and sees that all are passing. Next, he begins the merge to main process. He sees only the expected changes to breadcrumb entry, list entries, and the overview page, and clicks to review the page changes. They all look like what he expects, so he proceeds with the merge. He doesn't need to keep the working copy around, so he selects to delete it and clicks Confirm Merge. If it were an emergency, he could use the one-click remote deployment, but it's not, so he follows the normal process. A dean of the dev manager wrote this script that exports the 3 Woods Clinic apps to the team's local Git work area. The first line exports the onboarding app along with the database schema objects prefixed by FRC_, and the second 2 lines just export the library and clinic apps. Leo runs the script to export all the apps to Git. Leo uses VS Code to review the changes since the last time the team committed their work to Git. He commits the changes and pushes or syncs them to the team's remote Git repo on GitHub. Finally, Leo runs another team script that creates a build from their Git repo and deploys it to production. David tests out the fix in production and can now see all 24 months in the overview page charts. As we've seen in a team-centric approach, Apex developers use working copies to work in parallel on features or fixes, and then they merge to main. Periodically, Adina exports the team's progress to Git. Apex also supports feature-centric development, where teammates each work in private Apex instances on a Git branch per feature. See this technical paper for a complete overview of the Apex development lifecycle. Oracle Apex Service is scalable and extensible. It offers autonomous maintenance, patching, upgrades, and backups with auto-scaling of storage and CPU. Its multi-tenant model offers low prices of operation with built-in data security and is designed to support high availability and failover for 24/7 operations. Oracle's over 55 data centers around the world, 12 featuring Azure Interconnect, give customers flexible data residency options. Apex apps are easy to integrate with OCI metrics and support tools like Grafana to visualize them. This screenshot shows the Oracle Forums app that runs on Apex that gracefully handles over 1 million hits per day. Apex apps are easy to instrument with analytics like Oracle Infinity or other popular frameworks too. Apex has over 220 global partners, and the Apex World Marketplace offers over 400 components. Oracle Apex has 10 built-in authentication schemes supporting all the most common approaches out of the box. Its declarative authorization schemes give developers fine-grained role-based control over apps, pages, regions, items, columns, menus, and buttons. Apex Service uses transparent data encryption by default, and data is encrypted at rest. Data security can be implemented using virtual private database policies or database vault, and Apex offers numerous tools to proactively test apps for potential vulnerabilities. The built-in Apex Advisor audits application security and other best practices. Apex can export embedded application code so SQL can scan it for SQL injection vulnerabilities and potential performance bottlenecks. Apex Cert is an open-source app security scanning tool, while Apex Sec is a commercial offering from Regex that provides even more capabilities. Oracle Apex has built-in governance tools to manage resource access and monitor the use of the development and runtime environments. An Admin Digest provides recent trends of important metrics, accompanied by scores of built-in dashboards and reports. All monitoring and telemetry data are also available to create custom audits. Oracle Apex is the only LCAP platform so confident in its governance capabilities that it offers self-service provisioning to enable entire organizations to unleash the development productivity of every stakeholder, all overseen by a small ops team. The Apex community boasts over 800,000 developers who organize numerous conferences around the world. Apex comes with scores of sample apps, starter apps, and tutorials developers can use to learn the platform and improve their skills. Oracle also offers training and certification to jumpstart developers' career paths and bolster their CV. Over the last hour, you've experienced firsthand all of the unique differentiators that make Oracle Apex the world's most popular low-code application platform for enterprise apps. You've seen how Apex developers can do more with less, with off-the-charts developer productivity and AI assistance throughout the product. You've seen time and again how the original declarative data language gives Apex developers a leg up to work with any data using the same SQL skills, and how Apex's critical capabilities make it a leading choice for any use case. Thanks for your time, and visit apex.oracle.com for more information about Oracle Apex and how to try it out for free today.